Hey, well, hello everyone. It's a New Year's Eve podcast. It's a Ken Braverman podcast. So I drove halfway across the country over the last few days. I'm in Colorado, and I'm eventually heading out west and continuing to see as much of America as I can. I love checking out all parts of America. I was thinking about the YouTube channel here. We're at the end of 2022 here, December 31st. And I'm looking at, I had a goal this year to get my channel monetized, to get this thing up to enough watch hours is what I need to be able to put ads on these videos to actually make some money when I do video. Instead of just doing 1,800 plus videos and never getting a penny in ad revenue, which is the way it's been since like 2010. So I'm looking and I need to get to 4,000 watch hours. And as of right now, I have 3,751 watch hours. And that's like 250 short, 249 short. And I did a lot of videos about sports this year. I mean, I must have done over 365 because I feel like I did one almost every day and sometimes multiple videos per day. So probably like 500 sports videos. I'm going to run my video list and check, but that's like NFL stuff, which by the way, this is NFL, which I haven't really checked over that much. But did all these sports videos, and also whenever I talk to people and I send friends or acquaintances or whatever video links to things, I'm always sending them ones where I was physically somewhere and I'm in the video, visually, and there's a background of like me at like, on top of a rock at the Valley of Fire State Park in Nevada, or at the Grand Canyon, or in Telluride, or something weird place. And those are the videos I end up recalling back, or me rollerblading. That's the other thing, rollerblading through places, because there's some interesting stuff on these rollerblade videos I've done across the country as well. And so it made me realize that the sports algorithm stuff, as much as I would love for it to be this pot of gold where you just open it up every day and it just wins, like hockey just wins yesterday, all 4 games. And I did bet some of these games yesterday and I won money. I didn't bet all of them to win because I'm just so bad at betting. And so I just understood I'm bad at betting, and these videos are not getting the channel to where it needs to be, even though there's a very niche market of aware sports bettors that if you're going to actually bet on sports, why on earth would you not look at the algorithms rendering of look at there's like 90 games today. How many are there? There's 107 college basketball games today. I had to just run this for 10 minutes this morning, even though I don't want to pay attention to it. That's the whole point, is I don't want to focus on all this stuff all the time. I want to get out and live life and do other things. And also, I'm not going to go over the games. I'm sorry. And I'm not going to offer to sell this thing either. I'm just stepping away from sports. There's other people that are doing it. There's a lot of people that have contacted me and purchased copies of these, and I taught you how to create it yourself, and you realize how valuable it is. And I don't know why we have Princeton highlighted. Let's stop that. Anyway, you understand the value of this, but it's just so boring to talk about. And it's so, also, it doesn't result in you making $1 million every day. It results in you making more educated wagers and not getting surprised as much, and hitting a lot of stuff, hitting a lot of home teams. I mean, I don't know, but it's also gambling, and I don't want my channel to be about gambling. So I'm not going to talk about it. Instead, I've got this weird thing that says human sprap up on the screen, and it's got areas of the human cell. And so as I was driving across country and I was thinking about the year, and I was thinking about what I've done, and I'm definitely going to be looking at all the videos I've done this year to get an idea of what people watched, what I did this year. But I realized that I can't believe I haven't spent more time on this, being a complete vertically integrated model of the elements that are on the periodic table, which is what this is. All the elements, all the way up to the structure of the human cell and what it does, and reading of DNA, and basically the vertical code of how you go from elements that form bases and nucleotides, these things, adenine, cytosine, guanine, thymine. This stuff is really interesting if you really want to get into it, which is, can you believe that all biology is basically made up of these and a couple deviations of these compounds that are read in RNA and DNA. Like, isn't that amazing that it's not that many? Like, what? Like, really, it's just the composition of this and this getting read out in chains to then interact with everything that's going on inside of the cell. And there's like cells within a cell. There's like a powerhouse or a generator that's a mitochondria that's doing stuff within a cell that is read with a different set of DNA that you get from your mother. So you're splitting chromosomes, and like this stuff I can just talk forever and make completely, even I don't understand what I'm talking about, because I'm trying to put it all together. And that means grabbing all the data and identifying exactly how this works. And there are people, there are fields of study that have done this and are doing this. However, it's such a huge and enormous undertaking that when you have billions and billions of chains of these bases or nucleotides in order that are being read and replicated, and there's like, have you ever watched animation of what's going on in a cell and cell transcription and or DNA, RNA transcription, I believe? It is fascinating that it's basically like a ticker tape of all of these amino acids are being read by a 3-chain thing, which I believe is the lysosome or something. I got to learn more. That's why I'm actually happy that here at the end of the year, I have some direction. And it is, I can still do this. By the way, here's Saturday hockey. There's a ton of games for those who care. I'm not selling this, not doing it. This is the last day, the last time. I tried doing sports, everybody. I tried the whole freaking year. I tried all of November. I did not sell enough algorithms. I sold less than $20,000 worth of algorithms over the entire year, and I did all of them. I'm not happy with that, and I didn't get watch hours. So that said, well, Ken, go ahead and solve DNA. Figure out how DNA can be coded to create proper cell expression and alter everything when it comes to biology. Biohacking, do that, because that's more helpful to society. I agree with myself, and I'm going to do that. And we're going to create a dimensional cube of, I mean, me or whatever. It's easy to get DNA samples from me. So we might start with that. And I'm just going to go to town on this because this is worth it. And I'll be really proud of what this is at the end, because I already found out stuff about amino acids. All right. This is what I found out about amino acids already. This is what happens when you dig into the numbers, right? This is my big, profound assessment of amino acids. Notice how we have things called alanine, alanine, alanine here. That is four alanines. And there's a 3-character designation for it. Like when they talk about amino acids, which are chains, triplets of guanine, cytosine, adenine, guanine, cytosine, cytosine. That's what these are. This is really, you can put this thing together like Legos. It's amazing, really, with information that supposedly we have about something going on at this like dimensional level that we can hardly see or only infer what's going on. It's amazing. Now, well, what's going on here? This is the profound thing that I found out, that I understand why it's complicated to understand exactly what amino acid chains are doing sometimes, because you have 4 alanines here. And they're not the same. They're very similar, but they are not the exact same. And the reason why we do this is probably there are traits of these amino acids that are so alike that we decided not to make the amino acid table a designation table, which is this abbreviation. For example, alanine is A. Well, when you are coding a chain of amino acids, you need more than just A. You actually need to know whether it was like, I want to come up with my own abbreviations. And the way I'll do that is, well, I mean, let's just do this right now. Let's talk about really cool biohacking stuff, right? So these 4 alanines are not really the same. One is guanine, cytosine, adenine. The other is guanine, cytosine, cytosine, GCC or GCA. Well, those, you can see the adenine and the cytosine is the difference between these two that I'm talking about right now. Adenine and cytosine, well, what's the difference? Well, cytosine has 1 extra oxygen atom on the end, which I imagine would make cytosine much more reactive, because oxygen, you can see, like you do stuff with oxygen, it blows up. Oxygen is red because it's active. Like when you think about oxygen, there's a free-floating oxygen on the end of this one. And instead, there's 2 more nitrogen and 1 carbon on this one. I mean, these things are so different that it's obvious that this is not both alanine. Like one of them is alanine A1 and the other one is, I mean, they're separated by this. So you need to know which one this is. So when we do molecular diagnostics, we do it by actual nucleotide and sequence. I believe we don't do it by amino acid string only. So I believe they would solve that problem about realizing which alanine is in the was red as it is in the DNA chain or whatever. Is it this one or is it this one? And I do that. I have done something that analyzes sequences of DNA, and it is actually not in this file. Right, it's not in this file. So it's a sequence converter and it's a pivot table, and I've done it for specific viruses and things like I did it for COVID, right? And I did it for a breast cancer gene, and like I did it on a small enough level because you can do it in Excel. It's like 30. The COVID virus is like 29,000 bases long. It is not that long. And it fits in Excel nicely. And I've done analysis of everything, but I haven't continued to do it in depth, super in depth. But and I don't know if COVID is even worth it, although it kind of is. So the point is, I'm going to continue on that chain because I'm proud of this work. I'm interested in this work. It's going to get a different kind of audience, and it's going to get people who know a lot more than me piping in and telling me things that I'm trying to figure out on my own as I try to compile this all together. So I think it's the right direction to go. And I'm also going to be rollerblading around the country doing videos in person because those videos are fun and I'm proud of those as well. So I'm going to continue on this today. And when it comes to just like betting and stuff, just because I have this available, I can't make it a part of my life. But here's what I can do. I can click the underdog button and see that there's a bunch of underdogs. There's actually 3 home underdogs if these are true home games. That's fascinating. So like these are 3 picks I'm going to throw on a round robin for sure, because any home underdog has to be wagered on. I don't even care if it's not a natural home game. You still got to bet it. And look at the strength of schedule is all good. These 3 teams might all win. But I'm not going to make this my life, guys. I'm going to make this my life because this is life, right? I mean, this is unbelievable. I can't believe that you could like literally program anything biologically if you knew all its components in DNA and RNA, or like the DNA structure and its environment, because there's a bunch of other things other than how the DNA is assembled and read that dictate what happens in the cell. And there's like pHs going on, and there's just histories of how things get expressed. So it's really amazing, but I feel like I know you have to look at it on the molecular level in order to understand every single change, because one extra reactive oxygen atom in a different place might cause something to be weaker or change in the total just structure of everything to alter. And it's like, it's weird how the human genome especially is extremely resilient to oftentimes lead us to live long age, and our defective things that happen, I don't know, are sometimes mitigated. It's weird, all the things that go on in the genome, and we're just going to explore and learn it, because if there's anything to get totally excited about, it's being able to like program the solution to cancers and stuff like that, to understand it on a mathematical level, right? A component level, and program an answer, because then you could have robots doing it for us. It's too much for a human to understand everything that's going on, all interconnected all the time. There's too many tiny little things that are happening that it has to be an automated procedure that is calculations that are done by a computer, and a very powerful computer at that. Because I know that when I try to do analysis on something that's like a human cell that has 3.2 billion supposed characters of DNA, like nucleotides, 3.2 billion, supposedly a bunch of different chromosomes, right? 23 chromosomes, right? 23 me. So we got to get all the. I've done something for the chromosomes as well. I just don't have it open. I wasn't planning on really going as in depth into this in this video as we have, but as you can see, this is what I want to do. So I'm just going to do it, and this is not going to be an impediment really anymore. There's NFL. I didn't show it. Are there any good ones? The Bengals over the Bills. Do these teams care though? I see the Bengals. Bengals are good. Steelers over the Ravens. Tough game in Baltimore. Who's playing? I don't know. I don't care. I won't care until those games happen. And then maybe I'll revisit this, but I'm not doing videos and stuff. You know what? I'll talk about this, about what I read when I did it in the morning. If I did the sport, for example, a sport that's not up here is NBA. I didn't even do NBA because I just who cares? I don't want to watch it. I'm sorry. I just don't want to do it. I watch hockey. Hockey's fun. My Caps are playing today. Playing Montreal. Minus 275. Lingard probably going. I'll do some fun wagering and watching hockey while I do this. All right. Guys, that's the podcast. That's the end of your podcast. I'm sorry there are no more sports coming in my foreseeable future, unless, like I said, I talk about it while I'm rollerblading. I'll be like, oh, I'll be rollerblading in the middle of the Navajo reservation. I'll be like, hey, guess what? The Jets can beat the Seahawks, and it's only minus 124. I'll be like, I bet it. I bet the Jets again. I went out on the Jets in the season. That's my last bet of the year. That's how much I'm willing to accept what the algorithm says. The Jets away in Seattle. Sounds like that won't happen, right? But I'll probably do it. All right. Good luck, everyone. May all your picks be winning, and may all your what is that? May all of your forays into whatever you're interested in be rewarding and productive. All right. We're out. We're out in 2022. Welcome to 2023.